Let's take a look at this problem. We got f of x is equal to -2 times x plus 1 squared plus 4. Instructions say to graph it, and we'll eventually get there, but first find the x and y-intercepts. Well, to find the x-intercepts, you always plug 0 in for the other variable, so plug 0 in for y. Remember, f of x is the same as y. So we got 0 is equal to -2 times x plus 1 squared plus 4. And then we want to solve for x. So I'm going to take the 4 over, becomes a -4. Remember, when you take anything across your equals, your sign changes. Then I'm going to divide by the -2 because we want to get the part to squared by itself. -4 divided by -2 is 2. And that gives us x plus 1 squared. Now, the square root property. If you got something squared equal to something else, you drop your squared and you put a plus or minus square root on the other side. Then take the 1 over, it becomes a -1, so you got -1 plus or minus square root of 2 is equal to x. And those are x-intercepts. Okay, now our y-intercepts. You always plug 0 in for the other variable, so plug 0 in for x. So we're going to have y is equal to -2 times 0 plus 1 squared plus 4. 0 plus 1 is 1, 1 squared is 1, times -2 is -2, plus 4, which gives us y is equal to 2. Oh, and in point form, this would be 0, 2, and this would be -1 plus square root of 2, 0, and -1 minus square root of 2, 0. Now it says if it's in general form, convert it to standard. If it's in standard, convert it to general. Well, this is in standard form. So we got f of x is equal to -2 times x plus 1 squared plus 4. So to convert it, then x plus 1 squared means x plus 1 times x plus 1 plus 4. And then if I FOIL this, x times x is x squared, x times 1 is x, 1 times x is x, 1 times 1 is 1, plus 4. Combine some like terms, x plus x is 2x, plus 1, plus 4. And then if I multiply the -2 through, -2 times x squared is -2x squared, -2 times 2x is -4x, -2 times 1 is -2, plus 4. So it'll give us -2x squared minus 4x. -2 plus 4 is 2. And that's our general form. Find domain and range and the intervals in which it's increasing, decreasing. We'll ignore that for now. Identify the vertex. Well, if you got it in standard form, that means you can easily identify your h, k, and a. Now, whatever number is in the front here is your a. So we got a is equal to -2. Now, a negative means our graph's opening down. That's going to tell us a lot about our graph. Now, whatever number's here is our h, and it's always opposite sign, so h is -1. And whatever number's at the end is our k, so k is equal to 4. Now, if you have h, k, and a, you can tell some of these different items. Vertex is going to be hk, which is -1, 4. So that's our vertex. Then axis symmetry, which is what it's also asking for. is going to be x equals h. And h was -1, so we got x is equal to -1. Now our graph opens down, which means it has a highest point. So it's going to have an absolute max. And the absolute max is also your relative max, but it's going to be equal to k, which is going to be equal to 4. Some books write this in point form, so that'd be -1, 4 if they did that. Okay, now domain. Domain is always easy. For a quadratic, it's always -infinity, +infinity. Now our range is based upon whether the graph opens up or opens down. We said our graph opens down, so it's going to -infinity. Comma, and then the other value that we put here will be the y part of our vertex. The y part of our vertex is 4. Now our graph initially is increasing, I can see from this. So it's increasing from -infinity, and it stops increasing at the x part of our vertex, which is -1. And then you can see your graph's going down, so it's decreasing. So it's decreasing from -1 to +infinity. And let's start graphing this and see what we got. See, graph opens down. Okay. So our vertex is -1, 4. Which should be right there. And it's opening down. The y-intercept is 0, 2, which is right here. Now the x-intercepts are in radical form, which doesn't help me a whole lot. I'd have to convert them to decimal. Well, there's another way we can do that, and we'll find another point using that other method. And we said our axis symmetry is x equals -1, which means there's a invisible vertical line here. Oops. Boy, I kind of missed -1 there, didn't I? But you get the idea. Okay, what we're going to do is we're going to pick a data point. And 1 would probably be good. And we're going to plug x equals 1 back into the original problem. What was our original problem? -2 times 1 plus 1 squared plus 4. So again, I plugged the x equals 1 back in my original problem. 1 plus 1 is 2. 2 squared is 4 times -2 is -8 plus 4. And you get y is equal to -4. So the point would be 1, -4. So 1, -4 would be right there. Now that I have 2 points and a vertex, you pretty well have what your graph's going to look like. So it'll more or less look like this. By axis symmetry, it's symmetric to this line if I draw a straight line. So I could flip this, reflect it across that line, and that'd give me my right side of my graph. And yeah, that's a little bit too far out, but it's close enough. And that would be our graph.